This is the ST-Link V2 debugger. It has 10 pins, you can see clearly. And this is the STM32 FO11 CEU6 connected to the USB port. And here's how the integrated development environment uh, provided by the manufacturer. Okay, we hit debug and build, and currently it's suspended. Okay, I just hit resume, and here we have the global variable updating. Also, you can see the LED is blinking. Everything's working fine. You can see the program is running. We have our live variable, this global variable updating. To explain this code, I will suspend it. Okay. Now we have the standard header files. This is my function delay. I will explain later. Starting off with GPIO-C, as you can see the comment, this is the bit set reset register. Let me show you in the manual reference manual. You can see this is STM411 from the STM Micro Electronics. Let me show you from the beginning. Here we have the memory map. First, we'll see the GPIO-C. This is the base. You go here. You have the bit set reset register and the output data register. This bit BSRR corresponds to this output data register. We are avoiding this one because it it is vulnerable to read, modify, write race conditions. You can see the offset is 18. This offset is 14. Bit number 13 will modify. All right. Now coming on to the PC13 alias addressing. You see this was the output data register address which we use bit set register. Now uh, to turn off, you can see to turn off logic 1 is for turning off because this is active loop. To turn it off, we are using alias addressing, and to turn it off or turn it on, we are using this bit banding alias addressing. And here we have uh, actually, and here we are using bit set reset register. Okay, so we use let me explain you this how alias addressing works. Here's the bit banding part. See, one bit corresponds to a word here. Okay, so if you have to write the fourth bit, then you will need to multiply it by 4 words. That is exactly what we do here. Let me show you the memory map as well. Yes, see, this is the peripheral region which starts from here and up to here. Now we have the alias region here. We use the bitband alias base region and add the offset, multiply with 32. Now that is one word. And let me show you this will be better. Alias. See, we use the alias base plus peripheral offset. This is the offset that you need to climb past the base region and multiply it with 32. Now this whole is one. Now this is one word per word. And suppose you need to write bit number 3. You multiply it by 4 because each bit is mapped to a word in the alias region. And one word contains 4 bytes. Now quickly moving onto the this global variable. I've used volatile, so the compiler doesn't optimize it. This is a static handler. Interrupt increases the tick. This is a simple swap function added static to prevent dangling pointer. This is the system config file to enable the high speed clock and configure the 100 megahertz. configure 200. This is simple. This both are true. Simple arithmetics. Now we have the RCC, which is set to high speed bus 1. Uh, we need to set this 0, 1 to the second bit to turn it on to set it. Let me show you here. GPIO address. We go here, add our offset. This one. 30 offset we'll add, and we need to turn on the GPIO-C. So the 0, 1 to second bit we need to set. Likewise, you can see I've written this 4U in the comments. 4 is nothing but the second bit. Now we clear the 26 and 27 bit for the mode register. This is GPIO-C. Let's go to here, and here is mode register for A, GPIO A, B, and this is for GPIO C. Offset will be 0, of course, and we'll be modifying we need to turn the 13th bit because we are blinking the 13th LED. So 26 and 27 bit will clear, and we'll write on the 26th bit. So it will be 0, 1, which is the code, which is the uh, combination to set it to output mode. And you can see, yes, and now we are setting sysdig. You can see sysdig address. Here we are using the system provided struct. See the address. Set load to core clock, which is the number of ticks per second divided by 1000. So it is number of ticks per millisecond -1 because it starts from 0. This is sysdig val. You can write anything. The value will change to 0 because it is write reset register. And sysdig CTRL we use 7. You can add U. Doesn't really matter. 7 is 111 in binary, which is used to set the 0th, first, and second bit. Now I have an array. I use this to swap values in the swap function. Already told you returns pointer, static pointer. Here, this pointer stores the return value, the swapped value, store it back, and this loop runs again. The delay is simple. The only thing nice here is the overflow protection. And with the header files, I would like to wrap up my small project. Thank you.